So this is a Stefan Boltzmann apparatus. So this is heater. So this is you are having a evacuated chamber here which is having a hemispheric tube. So initially you have to allow the water to flow through this hemisphere. So you have to open this valve. So water enters here and heated water will be coming in this hemisphere. So remove the disc from the bottom of the hemisphere. So then you have to switch on the heater and allow the hemisphere to reach the steady temperature. So you have to wait for some time for getting a steady state temperature here. So then you have to know the temperatures T1, T2 and T3. So and you have to find the average of these temperatures in the hemisphere temperature. So T1, T2, T3. So this is your hemisphere temperature. So which is also provided here. So T1, T2, T3. So this is the hemispherical temperature. And T4 is the disk temperature. So you can take the value of T4 here. So this is T1 temperature, this is T2, T3, so which is hemisphere temperature, and T4 is the disk temperature. So next you have to refit the disk at the bottom of the hemisphere and start the stop clock. So this clock you have to on the buzzer, and also you have to on the stop clock. So there you can see the rise in temperature T4 with respect to time is noted. So up to T4, so in the value of T4, you can get the value of T4 here. So 35 degrees Celsius, it tends to increase. So for every 15 seconds, you have to know the value of T4. So after particular determination of time, so the value of T4 remains constant. So that is the steady state temperature. So also note down the disk temperature at T4 when steady state is reached. So then the area of the disk receiving the heat radiation, so and its specifications are given here, which is having a disk diameter of 20 mm, disk material is copper, and the disk weight is 0.008 kilograms. So this is the tabular column for your Stefan Boltzmann apparatus. So first you have to measure the hemisphere temperature. So that is T1, T2, T3. So those values you have to measure here. So that is T1, T2, T3. So these are the three values. Then T4. So it is the temperature of the disk. So this is your T4 temperature. So this is T4. So this value is going on increasing. Initially you can get 28.4. After 15 seconds it is 28.6. Likewise it increases. So after a particular period of time the value repeats 29.9. Again after 15 seconds also it is 29.9. So which is the steady state temperature. Okay, so then you can take the steady state temperature of the disk to be 29.9. So also this is the average temperature of the hemisphere, which is 41.2 plus 41.3 plus 40.7. Divided by 3 you can get this value. So this is hemisphere temperature and this is steady state temperature, which is noted every 15 seconds, and we are determining the steady state temperature. So how to put the calculations for this experiment is you have to determine the Stefan Boltzmann constant, which is denoted by sigma. So and its formula is Q divided by epsilon B into TH power 4 minus TD power 4 into A. So here Q is the mass of the disk into Cp of the disk into dt by dt. So which is simply Q equal to mCp into change in temperature. So by using this formula you can determine the value of Q. So we know average temperature of the hemisphere TH is to be T1 plus T2 plus T3 divided by 3. So which is already shown in the table. So like that you have to find the value of TH. So next is steady state temperature of the disk, which is TD, that is noted, which is 29.9 degrees Celsius. Then you have to determine the area of the disk, which is pi by 4 into d square. So that is diameter of the disk square, and its value is 0.00314 meter square. So from this known values we can determine the Stefan Boltzmann constant sigma equal to Q by epsilon B into TH power 4 minus TD power 4 into A. So this is your Stefan Boltzmann constant, which is sigma watt per meter square Kelvin power 4. So some basic constant values are mass of the disk, already said it is 0.005 kilograms, diameter of the disk is 0.02 meter, material of the disk it is copper, Cp value of this is 0.091 kilocalories per kilogram degree Celsius, and in terms of joules per kilogram Kelvin its value is 381 joules per kilogram Kelvin. So likewise you have to determine the Stefan Boltzmann constant for this experiment.